how to do the problems from the balancing equations take 2 worksheet. Yeah, hopefully this will help answer any questions you guys have. Okay, so for the first one, we have barium hydroxide yields barium oxide and water. So since we only have one thing for the yields, that means barium hydroxide is our only reactant. So when writing our formulas, remember to balance your charges. If we look on the periodic table, barium is +2, hydroxide is -1. So in order for those charges to balance out in our formula, we're going to need 2 of those -1 hydroxides to bottom with our 1 + 2 barium. We only have one reactant here because we only have one thing before yields, and then it's going to yield barium oxide and water. Barium, again, has a +2 charge, oxygen is -2, so we only need one of each to balance, and then we also have water. Okay, which we know is going to be H2O. So from here, okay, once we have our formulas written, now we want to make sure we have an equal number of all the elements on either side of the reaction arrow. So if you look on our reactant side, we have 1 barium, 2 hydrogens, 2 oxygens, okay, because we have that OH 2 times. If we come over here to our product side, again, we only have 1 barium. We're going to have 2 oxygen, and we also have 2 hydrogens. So if we look, we already have an even number of each element on either side of our reaction arrow, so we know it's already balanced. Okay, so looking at the next one then, we have C6, H12O6 is burned in oxygen. That means it is reacting with the oxygen in the air. Remember, when we have oxygen, that's going to be a diatomic element. So whenever oxygen is by itself, it's always going to be O2. And it tells us we are going to form carbon dioxide, we know is CO2, and water vapor. Water vapor, that's still just water, that's our H2O, it's just in a gaseous form. Okay, so if we look at our number of elements on either side, we start off with 6 carbons, 12 hydrogens, and 8 oxygens, because we have 6 in that first compound and 2 from our O2. And then on the product side, we only have 1 carbon, 2 hydrogens, and 3 oxygens. Okay, so here, since we have oxygen in multiple different places, we're going to do oxygen last, okay, because that's going to be the trickiest one. So let's look at carbon. On our reactant side, we have 6 carbons. So that means on our product side, we also need 6 carbons. So that means in order to get 6 carbons, we're going to have to produce 6 carbon dioxides, or 6 CO2. Okay? Now we have 6 carbons on either side. Okay. When we look at hydrogen, we start with 12 hydrogens on our reactant side. That means we also have to end with 12 hydrogens after a reaction. So if we have H2O, if we make 6 of those, we have H2 6 times. That means we'll also end with 12 hydrogens and we'll be balanced. Okay, now I need to relook at my oxygens on my product side now that I've added those coefficients. And I'll find that I have 12 oxygens for my 6 CO2s and 6 oxygens for my 6 waters. So I have a total of 8. Okay. I already have 6 in that first compound, which means I need 12 for my O2 in order for that to be balanced. So if I have 6 O2s, that means I have 12 oxygen atoms in total. Okay, so then looking for the next one, we have aluminum bromide. That's going to be AlBr3 because aluminum has a +3 charge. Bromine's only -1. And chlorine. Remember chlorine, that's another one of our diatomics, so that's going to be Cl2. And that's going to have to form aluminum chloride. Again, aluminum has a +3 charge. Chlorine's only -1, so it's AlCl3. And bromine. Again, bromine is one of our diatomics, so that's going to be Br2. Okay, so now we can start balancing once we have our equations written. Remember, we're looking at the charges when we're writing those individual formulas. And then once we do that, then we can look at the number of atoms. On our reactant side, we have 1 aluminum, 3 bromines, and 2 chlorines. On our product side, we have 1 aluminum, 3 chlorines, and 2 bromines. Okay, so if we look, we have one aluminum on either side, so aluminum's good. However, we have 3 bromines on our reactant side and only 2 on our product side. So we need to think, how can we get that 3 and that 2 to be equal? So we know 3 and 2 both go into 6. So if I want to have 6 bromines on my reactant side, that means I'm going to have to use 2 AlBr3s. Because if I have Br3 2 times, that's a total of 6 bromines. Likewise, if I start off with 6 bromines, I need to end with 6 bromines. So if I have Br2, I need to make 3 of those Br2s to have a total of 6 bromines. Okay? We're going to follow the same logic with our chlorine, because on our reactant side, we have 2 chlorines, and our product side, we have 3. We cannot end with more than we started with. So we know 2 and 3 both go into 6. So if we have Cl2 3 times, that means we have 6 chlorine atoms. And then if we need 6 on our product side then as well, we would need to make 2 AlCl3s, because Cl3 2 times is 6. Okay? And then since we added those coefficients there, we need to go back and check our aluminums. And if we look, we have 2 aluminums on our reactant side and 2 on our product side, so we're good to go. Okay, so then the next one, we have potassium metal. Potassium is not one of our diatomics, so that's just going to be K. And chlorine gas, chlorine is one of our diatomics, so that's going to be Cl2. These two combine to form potassium chloride. Potassium and chlorine each have a charge of 1, so they're just going to balance out right away. So then to look at the number of atoms, you can see we start off with 1 potassium, but we start off with 2 chlorines. And in our products right now, we only have 1 potassium chlorine. So it's our chlorines that are unbalanced to start off with. So in order, if I start with 2 chlorines, that means I have to end with 2 chlorines. So to get that to balance out, I'm going to need to make 2 potassium chlorides. And when I make 2 potassium chlorides, I get 2 chlorines, but I also get 2 potassium. So if I have 2 potassiums at the end of my reaction, that means I needed to start off with 2 potassium atoms at the beginning. So I'm going to need a coefficient of 2 in front of that potassium. Okay. All right. So looking at our next one, we have aluminum. On the dead spot, my computer. All right. Aluminum by itself, it's not a diatomic, so it's going to be Al plus hydrochloric acid, which I think it's given to you as HCl. They react, so these two are reacting together to form aluminum chloride. So aluminum has a +3 charge, chlorine's -1, so we need 3 of those chlorines to balance, and hydrogen gas. Hydrogen is one of our diatomics, so that's going to be H2. So then when we do our atom inventory, we'll see that we have 1 aluminum, 1 hydrogen, and 1 chlorine. After a reaction, however, we end with 1 aluminum, 3 chlorines, and 2 hydrogens. So we need these to balance out. Okay. So this one's a little tricky in that I have 3 chlorines on my product side, which means I also need 3 chlorines on my reactant side. So I'm going to need to put a 3 in front of this HCl. So now I have 3 hydrogens and 3 chlorines. However, if I look at my hydrogens, now I have 3 on my reactant side, but I have 2 on my product side. I need those to balance out. We know 3 and 2 both go into 6. So if I actually want to have 6 hydrogens on my reactant side, I'm going to need 6 HCl, so 6 hydrogens and 6 chlorines. And then I would need 3 of my H2s. If I have H2 3 times, that's 6 hydrogen atoms. Okay. So now that we put that 6 in front of our HCl, not only do we have 6 hydrogens on our reactant side, but we also have 6 chlorines. That means we'll need 6 chlorines on our product side as well. So we need AlCl3 2 times for a total of 6 chlorines. And not only do I have 6 chlorines now, but I have 2 aluminum atoms after my reaction. So that means I need to start off with 2 aluminum atoms as well. So I'll put that coefficient 2 in front of my initial aluminum. All right, so look at the next thing, we have calcium hydroxide. So calcium is +2 hydroxide, that's OH, that's -1. So we're going to need 2 of those calcium hydroxides. That reacts with phosphoric acid, which we know is H3PO4. They react together, so those are reactants to form calcium phosphate. Calcium has a +2, PO4 is -3. So we need 3 of those +2 calciums, 2 of our -3 PO4s to balance out those charges, and water. And to make this a little bit easier on ourselves, when we write water, we can think of it as HOH. And we'll see why we want to do that in a little bit. Okay, so once we start looking at our atom inventory, our calcium, we have 1 on our reactant side. Hydroxide, we can look at that as 1 group. We have 2 of those. We have 3 hydrogens and 1 PO4. Okay. So then when we look at our product side here, we have 3 calciums, 2 PO4s, and this is why it's helpful to write water as HOH. Because now I can see I have 1 hydrogen, and 1 OH. Okay. So when I write water as HOH, I can see how many hydrogen atoms I have on either side and how many hydroxide atoms I have. Okay. So if I want to balance this, I can see that we have 3 calciums on our product side, so we need 3 on our reactant side. That means we're going to need to use 3 CaOH2s. And when we do that, now we have OH 3 times, so we're going to have a total of 6 hydroxides, which means I'm going to need 6 on my product side as well. So that means I'm going to have to make 6 HOHs. Now I have 6 hydroxides and 6 hydrogens. I'm going to show them. When I think of water as H2O or HOH, I can look at my hydroxides on either side of my reaction arrow. And now I can look at my hydrogens as well. I have 6 just plain old H's on my product side, which means I also need 6 on my reactant side. So that means I'm going to need to use 2 of my H3PO4s, because H3 2 times 6. That means I have 2 PO4s on my reactant side as well now. And we can see that's how many we have on our product side, so we are balanced. Okay. So then our next reaction, we have copper, helium, and sulfuric acid, which they tell us is H2SO4. We have to form copper 2 sulfate, okay, +2 and a -2, so that's just CuSO4, and water, so H2O, and sulfur dioxide. Here, I'm just going to write water as H2O because we don't have a hydroxide anywhere on our reactant side. Okay, so in order to get these to balance, I can see on my reactant side, we have 1 copper, 2 hydrogens, 1 sulfur, 4 oxygens. Okay. And on my product side, I can see that I have 1 copper, 2 sulfurs, 2 hydrogens, and how many oxygens? 4, 1, and 2, so that's a total of 7. All right. So if I want to balance this, my copper, I have 1 on either side, so that one's already balanced. Looking at my sulfurs, we said I have 2 on my reactant side, or sorry, 2 on my product side. So 1 for my copper 2 sulfate, 1 for my sulfur dioxide. So that means I need 2 on my reactant side as well. So we're going to make this 2H2SO4. So when we do that, now instead of having 2 hydrogens, we're going to have 4, 2 sulfurs, 8 oxygens. Okay, so now we have 4 hydrogens on my reactant side, so I need 4 hydrogens on my product side. And we're going to get that by putting a 2 in front of that H2O. And when we do that, now we have 4 hydrogens, but we also now have added another oxygen. So we'll have a total of 8 oxygens in total on that product side, which is how many we had on our reactant side. So now we are balanced. Okay. So then for the last one, C7H16 and oxygen, we have to form CO2 and water. Again, I'm just going to write it as H2O because here I don't have a hydroxide ion. Okay, so looking at balancing, I have 7 carbons on my left-hand side, 16 hydrogens, 2 oxygens. And then on my product side, we can see that we have 1 carbon, 3 oxygens, 2 hydrogens. Okay? Here, since we have oxygen in multiple different places, we're going to wait to do oxygen until the end. So if we look at our carbon, we have 7 carbons on the reactant side, which means we need to end with 7 carbons as well. So we'll need to make 7 CO2s. Okay. So now we have 7 carbons on my product side and reactant side. Looking at hydrogen next, again, we're going to do oxygen last because it's in multiple places. I start off with 16 hydrogens, so that means I need to end with 16 hydrogens as well. So I need to make 8 H2Os. Okay, so when I do this now, I can check my number of oxygens. I have 7 times 2 oxygens for my CO2, 14, plus my 8 oxygens for my 8 waters. So I'm going to have 22 oxygens in total now. So in order to get 22 oxygens on my reactant side as well, I'm going to need 11 O2s because O2 11 times ends up being 22 atoms of oxygen. I hope that helped. Please let me know if you guys have any other questions. Otherwise, have a great day.